Today, ladies and gentlemen, is a big day. It's the day you learn about integration. It's like an eye-opening moment, Before you didn't know it existed, and now you know how to find out the area under a curve. Wow, what a transformative event in your life. Nevertheless, don't worry about this video being too difficult to comprehend. It might be a little bit of a step up, but I have made it easy to digest. And this is the first video in the series, so I'm doing an entire integration series. This is the first one. So you would learn this in the first year of A-level, essentially. And is it easy? I would say year one is pretty easy, okay? We're going to go through how to find the area under a curve today, the constant of integration, and definite integrals today, and indefinite integrals where you have to add a plus c at the end. You'll understand what that means in a second. Okay, so essentially, what I want you to do is leave a like, subscribe, put the bell on, because you might as well, and also leave a comment if you have anything that you're struggling with, and I'll try and help you as well as I can. Thank you. And enjoy the video. Okay, ladies and gentlemen, let's get started. So let's say we had a function equal to 3x squared plus 16. How would we differentiate that? Okay, so differentiation, you times by the power, okay, and then you minus 1 from the power. So then you'd get 6x, okay, and any constant, just you get rid of it. Okay, so essentially that means that way is differentiation. So integration is basically the backwards function of differentiation. So integration, and the formula is, so if you had x to the n, it would go to, you'd add 1 to the power, and then you divide by the new power, okay? That is the formula. Right, so if we wanted to integrate 6x, let's say, now the notation is, if I wanted to integrate 6x, I would write integral of 6x with respect to x, so I'd write a dx, okay? That is how you write the notation. So I would add 1 to the power, so you can think of it as 6x to the 1, right? You add 1 to the power, you get 2, you do 6 divided by 2, that's 3, so you get 3x squared, right? As the integral of that. Now the issue is, ladies and gentlemen, whenever we're dealing with indefinite integrals, we have to add something called a constant of integration, which is a plus c. Because if we even think about it, 3x squared and 3x squared plus 16. They're not the same thing, are they? When you differentiate, you get rid of the plus 16. So essentially, to factor that in, we add a plus c. And it's fundamental that you add the plus c, because if you think about it, over here, this plus 16, you get rid of it. So when you integrate back, all you get is a 3x squared. So to include the plus 16, you have to include the constant of integration, right? So don't worry about that. Just remember, always remember the plus c. Okay, let's go. Let's get started with some questions. The gradient of a curve is given by f prime x is equal to x squared minus 3x minus 2 of x squared. Given that the curve passes through this, okay. Right, so if we've been given f prime x as that, we rewrite that as f prime x is equal to x squared minus 3x minus 2x to the negative 2. Because obviously, you can write that as it's minus 2 over x squared. Right. Now, if we wanted to make this into f of x, we'd have to integrate. So we add 1 to the power divided by the new power. So it's 1/3 x cubed minus 3 over 2x squared. And then when we add 1 to negative 2, we get negative 1. Negative 2 divided by negative 1 is just 2. So plus 2 x to the negative 1. Now, ladies and gentlemen, a way that you can, oh yeah, and the plus c as well. Can't be forgetting the plus c. Okay, a way that you can check if your integral is right, essentially, is by differentiating it. So when we differentiate that, for example, we get 1/3 times 3, which is 1, and minus 1 from 3, it's 2, so it's just x squared. And then if we differentiate that, we get minus 3 over 2 times 2, which is minus 3, and then 2 minus 1, that's 1, so it's minus 3x. And then we do that, minus 2x to negative 2, and then plus c differentiates to nothing. Okay, that's fine. Now, we need to sub in values to find the plus c, because we need to find this plus c. Okay, we've been given 1, 1. It passes through 1, 1. Right, so when y is 1, we know we just need to sub in x is 1. So 1/3 brackets 1 cubed minus 3 over 2 brackets 1 squared plus 2 over 1 plus c. And then, okay, so we get 1/3. If I'm just going to put that into my calculator real quick. Okay, so we get 1 is equal to 5 over 6 plus c. So c is equal to 1/6. Okay, And that, ladies and gentlemen, is your final answer. You get 1/3 x cubed minus 3 over 2x squared plus 2x to negative 1 plus 1 over 6. Okay, right, let's go. The diagram shows a curve with equation y is 5 plus 2x minus x squared and the line with equation y is 2. The curve and the line intersect at the points A and B. Now this is an example of where we'll have to find something called a definite integral. Before I showed you indefinite integrals, now we're moving on to definite integrals and how to use integration to find the area under a curve. Okay, we're getting spicy now. First, we need to find the x coordinates of A and B. So essentially, we know that they intersect. Okay, the curve intersects the line, so we can set them equal to each other. So 5 plus 2x minus x squared is equal to 2. That means minus x squared plus 2x plus 3 is equal to 0. Okay, and then we just need to factorize that. So x plus 3 and x minus 1 is equal to 0. So x is equal to negative 3 and x is equal to 1. So essentially what we can do is find the area under the curve between A and B. However, there's this region here and we don't want this region here. And we can see that essentially our logical approach to this would be that we'd find the whole area under the curve. Okay, so that's this whole area, and then we'd minus the area of the rectangle. Okay, that's the approach that I'm going for. There's probably other ways to do it, but I think that is the most logical way to approach this problem. Okay, hang on, let me stop playing with my marker pens. Okay, so we know that the rectangle is going to be 2 high because y is 2 is here. So essentially the rectangle is going to be like that. It's going to be 2 up and it's going to be 4 across because that's 3 and that's negative 1. So the difference is obviously 4. Okay, so the area is equal to 8. Okay, right, we found the area of the rectangle. We just need to find the area under the curve. So we need to find the integral between negative 1 and 3. And obviously we need to integrate minus x squared plus 2x plus 5 with respect to x. Okay, now we add 1 to the power, minus 1/3 x cubed and plus x squared plus 5x. Now we don't add a plus c for definite integrals. We add square brackets and then we as so, and then we write the limits. These are called the limits essentially. Okay, so what you need to do now is you need to substitute the values in. So minus 1/3 brackets 3. Now this is rough. Plus 3 squared plus 5 brackets 3. Then you minus the minus 1/3 brackets negative 1 cubed plus negative 1 squared plus 5 brackets negative 1. Now if you do that, you should get 56 over 3 as your answer. And then when you do 56 over 3 minus 8, you get, let's see,